Welcome to Study Loop.
So we have this silicon type 2 superconductor. We're given the two critical magnetic fields. There's an external field here that's pointing in the x direction. So I've got this I hat here to indicate the x direction. And what we want to figure out is the magnetic field and magnetization when the flux just begins to enter the material in part A, and in part B, the magnetic field and magnetization at which the material becomes normal phase. So immediately, the first part is to realize that the question is actually asking for the magnetic field and magnetization at the critical magnetic fields. Okay, so the definition of the first critical magnetic field is that it's the field at which the magnetic flux begins to enter the material, just begins to enter the material. And the second critical magnetic field is the field at which the material becomes normal phase. So that's why we have C1 and C2 there. So per the definition of magnetization, we have this formula. So how do I know that this is mu0 and not some other mu? Well, the question mentions that the susceptibility is very close to 0, which means that we have mu naught in this case. So what about the magnetic field and the magnetization? So if we're near the critical magnetic field, what that actually means is that the field, the total magnetic field is actually 0. So what we have here is that the magnetic field is 0. That's the definition of the first critical magnetic field, right? So the flux is just beginning to enter the material. In other words, the magnetic field is sort of just barely 0. That's what's going on there. So if that's 0, what that means is that the magnetization is minus B0 over mu naught. Now B0 is exactly this magnetic field, right? It's the magnetic field of the first critical magnetic field. So this is minus 0.055 Tesla I hat divided by 4 pi times 10 to the minus 7 newtons per ampere squared, which is minus 4.38 times 10 to the 4 amperes per meter I hat. So that's the magnetic field and the magnetization near the first critical temperature. What about for B? So for B, once you're in the normal phase, again, sort of the definition is just that the magnetization is then 0, right? The material is not magnetized at all. But then if the magnetization is 0, we just have B equals B0. And now that's this field up here. That's the second critical field. So this is just 15 Tesla in the I hat direction. And that's the full solution to the problem.